Well, crap. Now I have to put this all back together again? Welcome to a video that takes hours and hours to make, but will probably take less than 30 seconds to bore about 99% of people. Today I'm going to rebuild an Edwards E2M0.7 lab pump, which I believe stands for 0.7 cubic meter per hour capacity. The process for rebuilding a pump like this is pretty straightforward, assuming you keep good documentation of how you pulled the pump apart, which I didn't do a very good job of. Consider this a lesson learned from my first time doing this. So the very first thing that you should do before attempting something like this is to really document with pictures or video where exactly everything came from and how you dismantled it, because you cannot count on Edwards documentation and quite possibly the documentation from whoever made your pump if you're doing it on a different model. I found an exploded parts diagram that claims it's for the 0.7 to 1.5 pumps, but there are some differences in how this pump was put together versus what's on that diagram. And the diagram also says E2M 1.0 and E2M 1.5 pumps, but the document title says it's for 0.7 to 1.5 pumps, with no special mentions for the 0.7s. So, yeah, there's some discrepancies here. One other thing that I would suggest is using gloves when doing the initial teardown and cleaning of any pump, especially if you bought your pump on the used market, since you may not know what nasty chemicals are residing in the residual pump oil. That said, we need to get ready for reassembly. This video stops short by one operation, the removal and replacement of the main shaft steel. To do this removal, I bent an old screwdriver in my vise to about a 45-degree angle so that I could more easily get under the seal that is really pressed into place and stuck there. I wanted to be really careful with this operation because you don't want to lever against the machined steel base and create dents and divots in it. What I found worked in the end was using the bent screwdriver to push the seal out from the opposite end and give it some good whacks with a rubber mallet. After getting the seal out, I went outside and brake cleaned the entire metal assembly to get rid of any residual gunk. Whoever had this pump before really ran it through the ringer. The filters were nearly all clogged, and I found what looked like a zeolite bead in the intake, some sort of hard ceramic. Thankfully, the input course screen had caught it. With the bearing out, it's time to inspect the contents of the rebuild kit. I purchased this kit from Inland Vacuum out of New York, I think they're based, along with some of their Inland 15 vacuum hydrocarbon oil. Hashtag not sponsored. They seem to do a reasonable job with selling me this kit, though I think I'm kind of spoiled by free Amazon shipping, as apparently UPS ground shipping on this kit plus a liter of oil was over $50. But every other vendor had free shipping on their oils, but were $50 to $60 a liter, so pick your battles, I guess. What I'm doing here is basically inventorying everything in the kit and seeing where it goes and what it replaces. I didn't want to clean out and throw out any of the rubber bits in the pump until I knew for certain that I had a replacement on hand. The rubber bits were generally in good shape, and I probably could have reused almost everything, but in the end, the kit was cheaper than buying the few parts that I needed, like the bearing seals and whatnot. This is a basic clean and service kit without the vanes, and they run about $120 and will replace every last rubber O-ring and seal in the entire pump. Since you're just tearing down the pump completely, you might as well replace everything just in case something might fail, and you'd have to end up spending several hours once again tearing the thing down again just for one measly O-ring. A big thing to note is that this kit covers 3 different pump models, the E2M0.7s, the 1s, and the 1.5s. You will have some spare parts left over that you have no clue where they go. On the 0.7, this included a couple O-rings and a filler plug that I decided to not replace since I like being able to change the oil and so on without a tool. If you're worried about someone pulling the oil plug on your vacuum pump without a tool because you don't need a tool to open it, you've got different problems. As I rebuilt this pump, I basically took each O-ring in the kit and tried to find its friend, and then when all the O-rings are exchanged, you should basically be ready to reassemble the entire pump. I also set aside all the old O-rings so that I would have them for reference just in case something else went wrong. As I went through the kit, I also took the time to clean any parts that I hadn't cleaned yet due to the presence of rubber parts that I didn't want to prematurely destroy. I also tried to avoid using brake clean or any special solvents on the vanes since I'm reusing them. This kit doesn't come with the vanes. You can buy kits with the vanes in it, but it's an extra $60–80 that I didn't need to spend. Since I'm reusing them, they seem to be some sort of glass-filled epoxy-filled parts. I'm not quite sure, but because I wasn't sure what they were made of, I just didn't want to destroy them with brake cleaners. So they only got wiped down real good with a rag, and ensuring that any brake clean on the metal parts are fully evaporated and removed before I put them back together. With the vanes cleaned, I just added a few drops of vacuum pump oil to pre-lubricate the vanes so that there was no chance that they run dry, rub, or get any damage during the reassembly process. It took some time to figure out where all the O-rings would go, and it was really the most time-consuming part of this rebuild process. The main pump body has a plug that needs to come out and also has an aluminum pass-through that needs to come apart to replace O-rings inside there as well. It's important to be careful pulling the aluminum out. One trick is to use other steel and metal to act as a lever spot so that if anything gets damaged or marked up, you do it on your tools instead of that on the pump body. Remember, when removing O-rings, be careful to not scratch the grooves in which the O-rings land. Don't use a sharp pick if you can avoid it, and if you do use a sharp pick, poke into the O-ring and remove it rather than using the sharp object to dig underneath the O-ring. It's really easy to dig into that O-ring groove accidentally when trying to lift out an O-ring, and you don't want to put a scratch. A plastic spudger or something like that will probably do a really good job as well. While a lot of these parts are steel, they can still be scratched, and on something like this, even a small scratch in the wrong spot could lead to nasty loss of performance. In this pump model, there's a taper pressure plug that is used to plug up a machining operation. This is all part of getting everything down to a simple bare metal as much as possible to aid in the full complete clean of every nook and cranny, since this pump was heavily used and did have a lot of dirt and crud on a lot of its surfaces. This is the plug that the main pump body also had, and like the aluminum pass-through, just be careful with removing the O-rings. Putting the O-rings back on the plug and the aluminum pass-through was not easy. They were quite tight, and you need to be careful to not scratch the metal or the landing grooves for the O-rings. After pre-lubricating the O-rings with some oil, the pump body can be reassembled now that it's nice and clean. I've put the main vane back in place and set that aside to do the filter. The old filter was really bad. While I could have cleaned it and reused it since it's just a bunch of wire mesh, it wasn't worth it, especially since it came with the kit anyway. I coiled the mesh screen around an Allen wrench so I could shove that into the filter body. You'll probably want to use a really fine Allen wrench, as the filter itself needs to be pretty tightly wound in order to fit into the housing. It took me a couple tries, but I got it in eventually. On the 0.7 pump, this side plug has an O-ring underneath it as well, which was one source of confusion for me while rebuilding this pump. Probably would be better to have a big screwdriver for this, but it works. A smaller one like what I used will just ding up the screw slot a bit. With the secondary pump body mostly cleaned and reassembled, we can now install the shaft seals as well. Ensure you lubricate the sealing surface and make sure the seals are oriented the same way they came out. They should end up facing each other in the opposite directions, as I recall, and that's how I've done it here. I used a drill press and the wide surface area of the NW10 fittings, actually, to press fit these into place. They didn't need a whole lot of force, but the big thing is to make sure your pressing surface stays parallel and your bearing seals don't go in crooked. At this point, it's really just figuring out and reversing the order of how everything went together. Gas ballast spring and ball bearing goes in. First stage rotary vane goes in. The tricky part is ensuring the shaft couplers line up. Line everything up and the main pump screws down into the pump body. Throw on the oil pump backing plate with 3 screws, and after that, the oil pump pickup can go on. Also, don't forget to replace the main body O-ring seal. Then the back plate at the vacuum pump, and you can start doing your full reassembly. And your pump is mostly reassembled, so it's time to do parts inventory and make sure you really reassembled everything properly and that you know where all your leftover things go, and then redo everything all over again. I found that I had left one spring out in the shaft that applies a tension onto the shaft. I also forgot the spring on the oil pump flapper, and there's also a spring under the intake port. But you won't have these problems like me if you properly documented how the pump came apart now, would you? Lastly, there's a bit of foam protection on the ballast valve that I'd forgotten. I was wondering where it went, or where this particular piece out of the kit went. It's easy to put back in place if you forget it. I think I might not have been on my pump and was probably destroyed after 30 years, hence my confusion. What really confused me on this kit was this plug that I had left over from my pump, and I had no clue where it went. I couldn't figure out where it went at all, until I went back and reviewed my old video and realized that the port and the part came from the kit, not from the pump. It had just been gotten greasy from my fingers on there, so it was actually just a spare. And I spent probably a good hour trying to figure out where that plug went. There's also an O-ring behind the glass oil sight that was a pain in the butt to replace. My best trick that ended up working for replacing this O-ring and keeping in place was to put the glass down first without the metal shield, and then put the metal shield over that, and starting to keep the shield and glass together while putting the O-ring into place. The metal shield and that glass are 2 separate pieces. They're not glued together as I originally thought they were. I also used this opportunity to clean a few of the exterior pieces of some of the 30 years worth of grime they had, just to make it look a little nicer and newer than it really was. Last step is to mount the motor back onto the pump body, pre-lubricating the seals of course, and making sure the shaft couplers are lined up well enough. Like me, you'll probably forget to put the carry handle back in place until it's too late. However, that's easily fixed by just loosening the body screws a little and then getting the handle back into place. With the pump now reassembled, give it the right amount of oil, about 200 milliliters in this pump's particular case, until you see the oil level in the glass sight appear where it should be, and then give the pump some healthy manual spins on the motor to get the oil pump primed and oil everywhere into the system before going full speed. Before you run at full speed, and you've run it a little bit, make sure the oil level's also at about the right level where it should be as well. It took me a month between rebuilding the pump and actually testing it, so when I first went to start up the pump, it was stalled. I actually had to manually spin the pump a few times to get it unstuck, but coworkers have told me that this isn't an uncommon occurrence with such small pumps, and not just limited to Edwards, but a coworker had one happen with a Varian Agilent pump, something like that, in the same size and class range, that every now and then you just had to spin it manually and get it running. As you can see in here, this pump is doing fantastically, pumping down to 30 millitorr in not too much time. It's definitely not as fast as my Robin Air 3 from Amazon, but it's a heck of a lot quieter and a heck of a lot less power. But it also reaches a lower ultimate pressure, and this pressure gauge was certainly not calibrated, reading 999 torr at 3,500 feet elevation, where ambient pressure really should be about 680, 700 torr, something like that. That's the pump rebuild. I hope you enjoyed it, and I'll see you in the next video.